A good place to begin an introductory statistics course is with a definition of statistics, or more specifically, let's say the statistical science. Now, what is then the statistical science? Well, back in my first day of grad school, my department head at Kansas State University told us that the statistical science is the science of data. This was back in the mid-90s, and nowadays we often think of the phrase data science. Well, that's what statistics is. And the reason is because statistics involves the collecting, classifying, summarizing, analyzing, and interpreting data. Now, there's other definitions out there. So, for example, one dictionary says that statistics is the mathematics of the collection, organization, interpretation of numerical data. And notice what I've highlighted here, especially the analysis of population characteristics by inference from sampling. This is going to be an extremely important part of our course. And you'll get a little bit of a taste for what this inference aspect is as we go along in these introductory notes. Now, another dictionary definition of what statistics is: a branch of mathematics dealing with the collection, analysis, interpretation, presentation of numerical data. To be honest, I don't like the part where it says a branch of mathematics. Statistics is not a branch of mathematics. That would be like saying engineering is a branch of mathematics. Rather, engineers and also statisticians use math to do what they do. Now, let me page down here. So most of what we will be doing in this course centers around trying to understand a set of information or data. Now, this set of information is often very, very, very large, and we cannot necessarily get at all objects in this this set of information, or this set of data, you could say. Also, I should back up for a second. In statistics, we often refer to these objects, when we're referring to all objects, as the population, or the population of interest. So our population could be, let's say, all people who live in the United States, or instead it could be all TVs that are manufactured by a particular company. And so what we like to be able to do is understand these objects in the population. And since there is just so many of these objects, what we will do is, instead of looking at every single one, which would be extremely difficult, is what we try to do is take a representative subset of information from this population. This subset is what's called a sample. And what we hope is that this sample is representative of the population, so that we could, let's say, look at information in the sample, make some judgments, and say what holds in the sample is likely to hold in the population. That's essentially what we do in statistical science. So let's take a look at an example. This is an example that I use in all my introductory stat courses that I've taught now and in the past. And what this example involves is, let's say that we're interested in estimating the average GPA of all students at our university. How would we go about doing this? And to make things a little bit more fun or difficult, depending upon how you look at things, let's assume we don't have access to actual student records. So we can't, let's say, walk over to the corresponding department, maybe the office of the registrar, and say, hey, could you give me all the GPAs of all the students here on campus? Let's say we can't do that. And instead, if we wanted to have all that information of all these GPAs, what we would actually have to do is ask every single student. So in this particular example then, the first thing that we need to do is define our population of interest. In this particular case, it would be the population of all students here. And again, as I mentioned before, there's going to be lots and lots of students. you're not going to be able to get at every single student, or if you do, it would take you a very, very, very long time. Also, we have, some other complicating factors here, and that is, students enroll late, students drop out as well. How do you take that into account then in terms of your population and getting at all those GPAs? Now, the second thing that we need to do is define our characteristic of interest. And in statistics, we refer to these characteristics as variables. So in this particular case, GPA is going to be our variable of interest. Very often throughout the semester, you'll see me refer to this maybe in a more generic term as X or Y. Then what we like to be able to do is define our parameter of interest. And what a parameter is in our statistics lingo is a numerical summary measure of information in the population. So again, a numerical summary measure for the population. And in our particular case, what we're interested in is the average GPA. So our parameter of interest is the average. In statistics, we refer to this typically as the mean. And since it's in the population, we have a population mean. Also, throughout the semester and even outside this class, very often you will see people refer to this quantity in a very generic manner as the Greek letter mu. Note that I am not saying mu as in what a cow would say, but instead I'm saying mu. Also, note that how this is denoted with a Greek letter here, I am not using the letter M. That would be incorrect. And so to kind of put a picture to what we have here so far in this example, we have, let's say, a big population, maybe thousands of objects, or in this case, students floating around in this population. Each of them has a GPA attached to them. And so what I've done is I've represented this big set of information by this circle. And we have these GPAs in there. And at the bottom, we have, well, how do we want to summarize it? We want to summarize it by the mean, or mu. So if we wanted to, what we could do then to find what mu is we take, 2.7 plus 3.6, and just keep on adding for all the thousands of students that would be in the population, divided by the number of students, and we will get our population mean mu. Again, that would be very difficult to do to get at all those GPAs. So instead, what we're going to do is take a representative set of students out of this population, ask them each what their GPAs are, and then find the mean value of those GPAs. So that means then we need to define our sample. So suppose that our sample is a representative set of 20 students taken from the population. I could take more, I could take less. As you might expect, if you take more, you're getting closer to the having everyone in the population, so you would think that that sample would be more representative of the population, and that is the case. But in most real-life situations, the larger this sample is, the more time, the more money it will take to actually obtain that sample. On the other hand, the smaller your sample, the less representative it will be of the population. And thus, information that you try to summarize in that sample is going to be, let's say, maybe less accurate of what it is for the in terms of representing what's going on in the population. So we will spend a lot of time in our course talking about, well, how do you choose a sample size? So stay tuned for that. But for now, let's just assume that I took a representative sample of 20 students. Now, each student's GPA is referred to as an observation. So in general, when we take a sample, we have these numerical values. Each numerical value is referred to as an observation. In our particular case, we are observing what that GPA is for a student. Okay? Then we can define our statistic of interest, and this is where the name statistics actually comes from. A statistic is a numerical summary measure of the sample characteristic. In this case, we were interested in the population mean. So our statistic here is going to be our sample mean. Again, the sample mean then is the statistic. And so a key aspect here, and perhaps I kind of jumped ahead there, a statistic estimates a parameter. Again, a statistic estimates a parameter. In this particular case, it's going to be the sample mean. And so, whatever your sample value is, I have one data value, or I have one observation plus another observation plus another observation. Take that divided by the number of students in sample. Very often statistics, the way that we denote what the sample mean is use the letter that's representing that characteristic and put a bar on top of it. And so this would be pronounced, for example, X bar. If instead we use Y's to denote our characteristic, we call it Y bar. Well, how exactly do we take this sample? Again, we want it to be representative of the population. And there are a number of different ways of how to take a sample. In fact, there are whole courses on that particular subject. We will focus on just one type of way to take a sample, the way that's most often done, and that is what's called a random sample. The word random comes into play because what we're going to do is basically assign an equal probability to every person in our population for whether or not they will be in the sample or not. And so since everyone has an equal probability, that's how the word random gets attached to it. Although there's other types of sampling methods where you can actually have different probabilities of selecting particular objects for your sample. We'll talk about that later. So again, a random sample is we select n items from a population where each has an equal chance of being chosen. So here's a nice picture that helps summarize what we've done so far. Again, we have this population that has lots and lots and lots of GPAs in it, and we summarize it down below by the population mean, mu. Since it's going to be so hard to get at all those GPAs in that population, we go into the population and we take out a random sample. And in this random sample then, we get what's called our sample itself. In this case, it's a sample of size 20. Of course, I couldn't put all 20 GPAs in this circle here, so I just ended up putting 4. So for example, 2.9 was in our sample, and notice how that was also in our population as well. This circle here representing the sample is purposely drawn to be smaller than the circle for the population to help represent that this is going to be a subset of the population, something that you can more easily work with. But similar to the population where we had the numerical summary measure here, the population mean, we're going to have our numerical summary measure here, X bar, our sample mean. Now, then we get to this inference part, which I brought up earlier. This again is going to be one of the main focuses of our course. So what an inference is a deduction or conclusion about the population based upon the sample. Again, and sorry if I'm repeating myself, we have this sample here, and we hope it's representative of the population. We calculate a statistic in the sample, and what we're going to try to do is infer then what's happening in the population in terms of what is the population mean. And as long as this sample is representative, we can generally do a good job. And in fact, we can attach a certain level of accuracy to it to help us understand, well, how good of a job have we done? And that's one of the really, really cool things about statistics itself in terms of the discipline. So as I say here, based upon the statistic in the sample, we will make inferences about the parameter in the population with a certain level of accuracy. This level of accuracy can be made through the use of probability. In fact, we will have a whole section in our course on probability. A lot of the items in it you will have seen before, but there will be other items that you have not. So now we can complete our diagram. We're going to use this diagram throughout our course to help us understand what we're doing and why are we doing it. So this sample here, based upon what we do, based upon our calculations there, we can make inferences about the population with a certain level of accuracy. Okay, so now we got some questions. The sample mean GPA, like X bar, estimates the population mean GPA. Is the sample mean GPA equal to the population mean GPA? Well, it would be nice if it is, but rarely will this ever actually occur. Because again, we're not, our sample is a subset of the population. It's not everything that's in the population. So generally, our sample mean is going to not be exactly equal to the population mean. And relating this to what we discussed earlier, the larger our sample size is, generally speaking, you would expect then this sample mean to be, let's say, a better estimate of that population mean. That generally occurs. There's a lot more to it than that, and you'll see as we go along in the semester. So how accurate then is the sample mean, GPA, in estimating the population mean? Well, that's what the statistical science is going to allow us to do. We'll get to that this semester. Suppose another random sample is taken, maybe another sample size of 20. Is the sample mean GPA going to be the same from one sample to the next? So, maybe the first time I got an X bar of, let's say, maybe 3.0. Oops. Will it be 3.0 for the next sample? Well, if I got exactly the same items or the same people in the sample, yes, it would be, but, rarely would you ever actually do that. And rarely would you find, let's say, 20 other people that have the same GPAs to get you to the same mean GPA. So rarely will it be the same. Maybe the second time I take a sample, I got 3.1. The next time, 2.95. Maybe the next time, 3.01, and so on. And what's really cool about the statistics discipline is we have a way to understand what this variability is in these numbers here if we were to repeatedly take samples of size 20. And we use that way of understanding that variability to our advantage. That's what's going to allow us to do things like confidence intervals later in the course. Well, last question. What would happen if a random sample is not taken? Suppose only students from a particular part of the university are sampled. Well, then this is where we get into the aspect of a representative sample. If I, let's say, just go out and find 20 of my friends and get their GPAs, well, that might not be very representative of the entire population itself. So this is where then one could have to worry about bias. That since you're not taking a representative sample, your estimate, your X bar, your statistic could be a biased estimate of that population mean, and we never want that to happen. So where exactly is statistics used then? Well, one place where I have a little bit of experience, I worked for a pharmaceutical copied before, is that statistics is widely used in the pharmaceutical industry. In particular, it's used for clinical trials in order to understand, for example, does a new medication that a company is developing, does it cure someone of a disease? And so you might, let's say, take a sample of 10 people, give them the drug, observe over time, are they cured or not? And then you might be left with, okay, let's say 8 out of 10 were cured. Is this going to generalize to the entire population or not? To make that judgment, to make that inference, that's where statistics comes into play. And so there's a lot of statisticians that work in the pharmaceutical industry for that purpose. Another example from the pharmaceutical industry that I've worked on is to determine the shelf life of a pharmaceutical drug. So, whenever you get, let's say, some kind of maybe like a little bottle of pills from a pharmacist, on that bottle of pills, you're going to see some kind of expiration date. Well, how does that expiration date, how is it calculated? Well, that's where statistics comes in. In fact, towards the end of the course, we might see an actual example of how that's done using a technique called regression analysis. Statistics is widely used in agriculture. In fact, most departments of statistics, when they were first starting to be organized in the 1930s, 40s, and 50s, the reason why they were organized in universities was because of agriculture. People in agriculture needed help analyzing their data, and so these departments of statistics popped up. So, for example, again, I went to Kansas State University for my PhD, and a big topic was always, well, what variety of wheat is going to have the largest yield? Well, how do you figure that out? Well, that's where statistics comes in. Statistics also, let me page up here. Statistics also is widely used in marketing. So have you ever received a something in the mail about, hey, you have been pre-approved for a credit card? Well, why did they select you? Well, unfortunately, you have some statisticians to at least partially blame for that, because statisticians develop statistical models to estimate then the probability that, yes, this particular person will take the company up on their offer for a credit card. Another place in marketing is with respect to, for example, Hallmark cards. I've had friends who've worked for Hallmark in the Kansas City area, and they do stuff such as which cards should be marketed to the public. Another place where statistics is used is with respect to forecasting the future. So one place where I've been involved, and this is always important to universities, is, well, what's going to be the enrollment of next fall at this university? How can you forecast what it would be? Well, and also, why would that be important? Well, university administrators need to plan. They need to have enough classes available for students. They need to have enough faculty available for them. They need to have, let's say, enough residential halls available for these students. And so forecasting future enrollment is a big place where statistics is used. Companies also, of course, need to, let's say, forecast what their profit would be for the next year. So here's some really good quotes about statistics. So the first one's from an American Statistical Association president. And he said, "I like to think of statistics as the science of learning from data. It presents exciting opportunities for those who work as professional statisticians. Statistics is essential for the proper running of government, central to decision-making in industry, and a core component of modern educational curriculum at all levels." Here's another quote. So many of you have heard of Florence Nightingale, and you probably know her from her being a nurse in the mid-1800s to about the year 1900, and she's famous for improving the hygienic practices of the military for the UK during a particular war. And the way she made her judgments about what works and what does not work was through statistics. And so because of that, Florence Nightingale is often thought of as a statistician as well. She was a member of the Royal Statistical Society too. And here's her quote. This is one of the best quotes in all of statistics. She said about statistics, "It's the most important science in the whole world, for upon it depends the practical application of every other science and of every art. The one science essential to all political and social administration, all education, all organization based on experience, for it only gives results of our experience." So in other words, let's use past experience, the data that we've gotten from past experience, to make judgments, to make inferences about the present or the future. So if you're interested in knowing more about statistics, here are some links corresponding to the American Statistical Association, which is the largest association for all statisticians. It has about 20,000 members. So why are you here then for this particular course? Most of you are not going to be statisticians. We do often have a number of students who choose to get a second major or a minor in statistics. So why are you here? Well, of course, it's because your advisor made you take the course. Hopefully that's not necessarily the only reason. Generally speaking, for a course like this, the reason why you're taking it is because you will be at some point needing to analyze some data, and you may not necessarily have all the necessary skills to do that. And so because of that, you might need to work with a statistician. And by taking this course, you'll learn the basis of statistics so that when you communicate with the statistician, when the statistician communicates with you, you can communicate well. You understand the same, a lot of the same words. Now, some of you might also end up getting to perform some of your own statistical calculations. Depending upon, let's say what kind of experiment you run or what kind of data you have. Maybe that kind of data might be simple enough. I don't mean simple in a bad way, but simple enough that you could do it on your own. Okay, so this course will give you some of those basic skills. And some of you will also want to take additional courses in statistics so that you can learn better about how to do the calculations on your own. We have many courses that are what we refer to as mixed major courses, where about, let's say, maybe half the students in the course might be statistics majors, and the other half are non-statistics majors. And those are often some of my more favorite courses to teach because we get a lot of different perspectives on it, or on the topics that we're talking about. Okay. So lastly, let's end with this. So what are we going to be doing in our course? Well, basically, we're going to be looking at all parts of this diagram throughout the course. And as I mentioned earlier, I will often go back to this diagram so that you can see where we're at and so that you can remember why we are doing what we're doing. So I've divided the course up into sections, for the lack of a better name. And so right now we're doing section 1, Introduction. Next we will do section 2, which involves summarizing data, where we're going to take let's say you get a data set and you want to take an initial look at it. So you might calculate some simple summary measures. You might do some simple plots. We'll take a look at that to make sure all of you have the basic experience or basic knowledge of how to do that. Then we will talk about probability, where we will define it in some formal mathematical ways. And again, the concept of probability is what's going to allow us to make this inference from the sample to the population. And then lastly, basically for the bulk of this course, we will talk about inferences. And this will allow us to put all parts of this diagram together. And we will look at how to make inferences in a number of different scenarios, such as you have one population mean. Excuse me. How do you make the inferences? Well, maybe you want to compare two different population means. How would you do that? Maybe you might be looking at proportions, or maybe you want to look at relationships amongst multiple variables. How do you do that? How do you make the inferences? How do you do it properly? So that's what we will be doing then in our course.